Expression is just a fraction with a polynomial on top and a polynomial on bottom. If it's just an integer on top or bottom, it's not a rational expression. It has to be a polynomial in the numerator, so x cubed, a polynomial, and then a polynomial in the denominator. Okay? Multiplying and dividing rational expressions is a lot easier than adding or subtracting them, which seems counterintuitive, but that's the way it is. So just as a review, I'm going to do a multiplying, that's a 2, plus 9x times x squared plus 8x for negative x squared plus 11x plus 12. Okay, with a polynomial like this, rather than just jumping in and taking this times this and this times this and then dividing the two, factor when you can. Okay, so how do I factor the numerator on the left? Can I? I'll make this a minus 36. That might help. $12 and 3. Yep. So this is x plus 12, x minus 3. How do I factor the bottom? Difference of two squares.
So x minus 3.
Okay, let's keep going. Factor the numerator over here. What's that? Yeah, let's factor out a negative 1 here and make this negative x squared minus 11x minus 12. Because we always, when we factor, we always want to make sure that that first term is positive.
So negative 12 and then plus 1.
Okay, so now we've got this where we can start crossing out things. X minus 3, x plus 3. I have an x plus 12 on top and an x plus 5. And on bottom I have a negative x minus 12 and x plus 1. So I could, if I went ahead and if I put the negative in, this is not going to match up with this. It's going to be negative x plus 12, right? And I want to make sure 12 needed to be negative. Yes. So now I could go ahead, I could leave it in factored form like this, which is fine, or go ahead and multiply both of them together to get a polynomial on top and bottom. Okay, multiplying works this way. Dividing is almost exactly the same, except if I had divide here, what I'm going to do is flip those and multiply.
On both sides or
Just the one side. So if this was divided by this, yep, I'm going to multiply by the reciprocal. So I'm going to take this and I'm going to flip this and multiply the two, and then do the same process. So it's just one more step when you divide rational functions. Just multiply by the reciprocal. Multiply by the flip of whatever it was. Okay, so multiplying isn't too bad. It's when you're adding and subtracting that it gets a little more complicated. So, let me get to one of those. If you have like denominators, it's not too bad. like this. Like denominators, treat it just like fractions, add the numerator and put it over the denominator. The key here is, if this is plus, that's pretty easy. If it's minus this whole thing. So you've got to remember to distribute the negative. So in the numerator, this becomes 5x plus 3 minus 2x minus 9. 5x minus 2x is 3x. 3 minus 9 is negative 6, which I can then factor in the numerator. The bottom factors, this cancels. My answer is 3 over x plus 2. Did you follow? Okay, I subtracted 2x and subtracted 9. I simplified my numerator to get 3x minus 6. I factored out of 3 to get x minus 2. I factored my denominator to be x plus 2, x minus 2. Canceled my x minus 2's, and I'm left with 3 over x plus 2. Okay, so if they're the same denominator, it's pretty easy. If they're not, we have to get the same denominator. So that's where it gets a little more complicated. So let me do one of those. Do a couple of those, actually. Let's start with something relatively easy. Okay, these are not the same. Everybody agree? I need to factor this first before I even start evaluating. So when I factor this, it becomes that, right? So now when I look at my two denominators, what is my common denominator?
Wait, no.
This is the hardest part about these, finding the common denominator. Let's say I had a denominator of 3 and a denominator of 3 times 4. What's my common denominator? If I'm going to add a fraction, 5, 12, right? If I had 1/3 plus 5/12, my common denominator is the product of these two. Okay? So now instead of numbers, I have variables representing numbers. So if this was 3 and this is 3 times 4, my denominator here is x times x plus 3. That's what I need to get to become the common denominator. So when I look at this ratio, this fraction, what is missing in the denominator to get this? X. So I need to multiply top and bottom by x.
If you multiply the bottom, oh, never mind. Never mind. You get some.
So on the top I have x squared plus 2x plus x minus 1. On the bottom I have x times x plus 3, because this needs to be distributed to both terms. Now I'm going to simplify and see if I can reduce anything. X squared plus 3x minus 1 over x times x plus 3. This is not factorable on top. So that's as simplified as I can get it. But we always have to try and simplify if we can. Okay, let's do one that's maybe a little more complicated. Okay, I always want to factor first, if I can. Can't really factor anything on the left, but I can try and factor this. Bottoms up method. Right? So it becomes x plus 3 times 2x minus 5. Okay, so what does my common denominator need to be? This, right? I'm missing x plus 3. Eight x, 24, and be careful, minus x minus 5. Minus x minus 5, not plus 5, to distribute that negative to both terms. All over. Okay, now let's simplify the top. I have 7x and plus 19. You can't simplify that anymore. The fun ones happen when you actually get something here that you can then simplify, and it just reduces even further. This is what I call fun. Let's do one more. We haven't talked about polynomials yet. I'm going to do one right before this. Stop. How does this factor?
3 and 2.
X minus 3, x plus 2, right? Which is what I have here and here. So I'm close. This is going to be my common denominator. So I need to multiply this times x minus 3. This times x plus 2. Okay, and this I don't have to do anything because it's already there. So I have 2x minus 6 plus 3x plus 16 minus 2x minus 4 minus 4. Okay, I kind of skipped a step. It's 2x plus 4 here, but then it's subtracting that whole thing. So you've got to distribute your negative. This is where you're going to mess up. You won't think you will because you get it now, but you're going to mess up. So in order to not mess up, remember, do this, take the extra step, and distribute. I know because I've messed up enough that I know it now, and I just do it as I go. But until you get to that point, write it out. Okay, and this is all over x plus 3, x minus 2. Okay, so now just combine like terms. 2x minus 2x cancels. I have 3x. Negative 6 plus 16 is 10. Minus 4 is 6. And then I have, what, 3 times x plus 2. I was so close to having my day made. So close to being able to cross them out one more time. But I'm not there. So that's as simplified as it's going to get. Okay, so this section, we covered adding, subtracting, multiplying, and dividing in 2 or 3 lessons in Algebra 2. We're just reviewing those 3 in 1 lesson today. Okay, getting a common denominator to add or subtract, multiply and divide, factor as much as you can, see if you can cross things out before you go into actually multiplying polynomials. Okay, and to multiply or to divide, you're just multiplying by the reciprocal of the second one. And then doing the same thing as when you're multiplying. Questions on any of these? I'll look and tell you what numbers in WebWork this covers.